Welcome to the FAA's Teterboro Airport Community Engagement video. This video is part of the FAA's video series for the New York, New Jersey metropolitan area. This video will provide a basic explanation of how the Federal Aviation Administration's air traffic control system works at Teterboro. The New York, New Jersey metro area is one of the most complex and busiest airspaces in the world. It includes more than 50 airports operating commercial and business aircraft and helicopters in the most densely populated area in the country. Teterboro is in the heart of this busy airspace, surrounded by major international airports, including Newark International Airport in New Jersey, JFK, and LaGuardia in New York. Teterboro Airport is a general aviation reliever just 12 miles from Midtown Manhattan. As a reliever airport, it does not offer scheduled airline service, nor does it permit aircraft operations of more than 100,000 pounds. Its focus is to provide facilities that remove non-scheduled general aviation aircraft that would cause significant congestion at the surrounding commercial airports. The most important responsibilities of an air traffic controller are to ensure airplanes are safely separated from each other and from obstacles, including terrain, while maintaining the most efficient flow of air traffic. Accomplishing this task is complex, labor-intensive, and requires great precision. As aircraft fly from one airport to another, they are transitioned from a controller in one airspace to another to complete their journey. Controllers in the Teterboro Air Traffic Control Tower focus on landing, taxiing, and departing aircraft at Teterboro. Controllers in the New York Terminal Radar Approach Control are responsible for aircraft flying within the New York, New Jersey region between airports. If aircraft are flying to or from airports outside of the New York, New Jersey region, they are overseen by controllers in the New York Air Route Traffic Control Center. In a busy airspace like New York, a single controller is responsible for simultaneously directing aircraft from multiple airports within their airspace. Air traffic controllers use flight procedures to safely manage this complex, three-dimensional interaction throughout the national airspace system to ensure safety and efficiency. These predetermined routes in the sky are designed to keep flights clear of obstacles and terrain, providing safe passage through the skies. When used in combination with other procedures, they may also safely segregate air traffic flight paths from each other. Each airport has its own airspace with dedicated arrival and departure procedures that serve all classes of aircraft, from the largest commercial and cargo aircraft to helicopters and small propeller aircraft. All flight procedures are designed to fly in the appropriate airspace in accordance with regulations. Teterboro Airport has two runways, Runway 624 and Runway 119. When an airport is first constructed, the runways are built to align with the most common wind directions in the area. It is safest for aircraft to take off and land into the wind. In the New York area, winds frequently come from the southwest and northeast. Therefore, most airports in the greater New York area have primary runways aligned from northeast to southwest and typically have crossing runways. Runways are numbered following a 360-degree compass pattern. For example, at Teterboro, runways align northeast and southwest from 60 degrees to 240 degrees are given a shortened name, Runway 624. The second runway positioned on an angle from 10 degrees to 190 degrees is named Runway 119. At Teterboro, winds are typically from the south and southwest. Therefore, the most common operational configuration is landing on Runway 19 and departing on Runway 24. Aircraft arriving at Runway 19 approach the airport from the north and line up with the runway end before landing. Aircraft that depart Runway 24 fly the runway heading of 240 degrees, then turn based on the flight procedure used. In addition to wind direction, runway selection at each airport is also determined from several factors. Weather, runway availability conditions, and operational considerations are determining factors. Airports in the New York airspace operate dependently due to their proximity. Therefore, when one airport changes its runway configuration, other airports may also need to change the runways in use. We'll now show how Newark, Teterboro, and other airports interact with each other. Teterboro and Newark airports are about 12 miles away from each other, and it can take at least 30 minutes to travel between them on the highway. But in the air, with aircraft traveling over 200 miles per hour, this means the airports are only seconds apart in the sky. Due to the close proximity of the airports, their flight operations affect one another. Therefore, when Newark changes the runways in use, Teterboro must also change the runways in use. This animation shows that air traffic controllers must keep the arrivals and departures from each airport safely separated, both laterally or vertically. For example, when aircraft at Teterboro depart runway 24 headed south, they must turn to the west to maintain separation from Newark arrivals and departures. Maintaining separation ensures aircraft maintain required safe distances from each other, laterally or vertically. Teterboro and Newark are also in close proximity to Essex County Airport, Morristown Airport, and LaGuardia Airport. The flight paths of these airports often cross and shift based on wind conditions and traffic volume. Air traffic controllers continuously manage this three-dimensional interaction throughout the day. The FAA has standards on how close aircraft can operate to each other. These are called separation standards. Aircraft flying at the same altitude must remain a minimum lateral distance from each other. In airspace surrounding airports, the minimum lateral distance is 3 miles. In higher altitude airspace, the minimum lateral distance is 5 miles. If aircraft don't meet the lateral distance separation requirements, they must remain a minimum vertical distance from each other. In normal flight altitudes, the minimum vertical distance is 1,000 feet. The FAA developed an offset arrival procedure for Runway 19 at the request of the Port Authority of New York and New Jersey and Teterboro Airport Noise Abatement Advisory Committee. When an aircraft lines up to land, they are usually lined up with the extended runway centerline for at least 5 miles. An offset procedure lines up an aircraft at a slight angle to the runway, then aligns with the runway centerline closer to the airport. The Runway 19 offset procedure was implemented to avoid noise-sensitive areas, including a hospital and residential areas. The offset procedure is available for use upon pilot request unless there is poor weather, low visibility, or high traffic volume. This procedure exemplifies how the FAA works with communities via working groups or roundtables to develop consensus-based flight procedures. High traffic volume and surrounding airports are factors taken into consideration to safely and efficiently direct aircraft through the national airspace system. This video provides a basic understanding of how the air traffic control system functions at Teterboro Airport. For more information, please visit our website.